Hi, welcome back to Intermediate Algebra. 7.4, quadratic form. So these are going to be equations that are a little bit different, but we're going to use some tricks that we know from doing quadratics, and we're going to kind of force them to work that way. That's my really kind of simple explanation. We'll make it more complicated. Sorry. All right, so basically they look like AU squared plus BU plus C is equal to 0, where u is some other expression. And so we'll see an example here in just a second behind me. Basically, the middle is going to have a piece, and the first term is going to have a piece, and one will be a square of the other. So let's look at a real simple example, and then we'll move into some a little bit more complicated ones. All right, so here's my first example. X plus 1 squared plus 2 times x plus 1 minus 8 is equal to 0. Now, we could expand these parentheses and distribute here and combine all of our like terms and be left with a regular quadratic just fine. This is kind of one of the ones where quadratic form isn't quite as necessary. But there is actually an easier way. I'm going to do some substitution. I'm going to call u, I like u, it works. You can use any letter you want. Don't use x. You don't want to get it confused with your actual x. So I'm going to call u x plus 1. And looking at this equation, I picked that because here I can see x plus 1 to the first power, and here I can see x plus 1 to the second power. So it works very nicely to just call the x plus 1u, because then I have 2u here in the middle, and I have u squared at the beginning. And now this is a quadratic. Okay, it's a quadratic with a little twist that we're going to see, that we see there, and then we'll see again at the end. So we're just swapping out these expressions, the x plus 1s, for u's because it makes something easier and nicer to solve. Now, at this point, we have a quadratic. You could complete the square. Almost nobody ever picks that one here. You could use the quadratic formula. That's always really popular. Or, in this case, it factors very nicely to be u plus 4 times u minus 2 equal to 0. And since I like factoring, that's the way I did this. Once I had it factored, I split it up and set each piece equal to 0. Subtract my 4 and get u equals -4. Add 2 and get u is equal to 2, which is great and fantastic, but we're not done. We weren't trying to find u. We were trying to find x. So we have to go back and substitute back in. So we know that u is -4, but we know that u is x plus 1. So I just bring that x plus 1 down and say, okay, well, if u is -4, now x plus 1 is -4. And that's a real easy little piece to solve. Right? I just subtract 1 and I get -5. Same thing over here. I subtract 1 and I get 1. And now I have my two solutions, -5 and +1. And we're pretty happy with it. So using quadratic form is just a way to kind of clean up a mess sometimes, so that you can take something that's a little bit messier, that would be a little bit more work, make it into something simpler, and then have a little step here at the end to finish it off. So anyway, that's what we're looking at. We're going to do two more examples. They're going to get a little trickier here for the next two, but it's still going to be the same basic idea. We're going to try and find an expression that exists that is both here, it's usually in the middle, and then it is at the beginning, and one is to the first power and the other one is squared. So let's get another one. All right, so here's my second example. X plus 3 square roots of x minus 18 is equal to 0. So this has a square root of x in it, and we learned to solve those in chapter 6. But this particular one actually works out just a little bit nicer than if we try and isolate the square root, square both sides. It's going to be a bit of a mess to do that because we have all these terms running around. So instead, what I notice is this. X is the square root of x raised to the second power. Right? If you square a square root, the square root goes away. So I'm going to take advantage of it and do some substitution. I'm going to call u that square root of x that's in the middle, which would make u squared just plain x. So since I can do that, I can rewrite this now as a quadratic. U squared plus 3u minus 18 is equal to 0, because quadratics are frequently nicer to solve than things with square roots. So again, this one factors. And so I factored it. I got u plus 6 times u minus 3 is equal to 0. That means that u plus 6 is equal to 0 and u minus 3 is equal to 0. Subtract 6 and get -6. Add 3 and get 3. So I have the solutions now for u. I still need them for x, but I have them for u. So let's just kind of see that again real quick. I just took that and I made u and u squared. Here's a hint, that's usually where they go. And then I solved it. Now, could I have solved this quadratic in some other way? Absolutely. Again, you could complete the square. Most likely, if you don't want to factor it, you're going to use the quadratic formula. All right, but I'm not done because I only have values for u. So now I have to go back. Well, what was u? U was the square root of x. So now I'm going to replace these u's with the square root of x. So I get the square root of x is equal to -6, and the square root of x is equal to 3. The second one here causes no problems. Square root of x is certainly capable of being equal to 3. So I square both sides and get 9. However, the first one, the square root of x is equal to -6, that's not actually possible. Right? You can't get a square root of something to be just a negative number. You could get a square root that spit out an I, right? You could take the square root of a negative and get an I, but you can't have a square root that just spits out a positive square root that just spits out a negative number. So that's impossible. This is an extraneous solution. And as we hopefully remember from chapter 6, when we did radicals, we know we have to be really careful to make sure that our solutions actually work. But in this case, that one doesn't work, so we'll just go ahead and cross it out. We'll keep the 9 because it does work. If you don't believe me, feel free to plug it in. It will work. So there you go. There's our second example. I have one more that I want to do for you, and it's really going to be fun. So here we go. All right, so here's our last example. And like I said, this one's kind of a doozy. It's definitely a mess. It's gonna really make some interesting things happen. So let's take a look at it. I have 12x to the 4th plus 4x squared is equal to 1. For starters, it's not actually in quadratic form yet. I need 0. So I subtract 1 and get my 0. 12x to the 4th plus 4x squared minus 1 is equal to 0. All right, that was the easy part. Now for the little bit more interesting bit. So I still need to change this to u and u squared, and it's going to work out nice, or reasonably nice, I guess, if we call u x squared. And that works because, remember, if you square a square, if you raise a power to a power, you multiply 2 times 2 would give me the 4th power. So if u is x squared, when I square that, I get x to the 4th. So I can make my substitution. Now I have 12u squared plus 4u minus 1 is equal to 0. And that's definitely nicer, right? No 4th power. Who wants to solve something with a 4th power in it? We haven't even covered that, so how would you even do it? This is one really good option. Anyway, so I chose to go ahead and use the quadratic formula on this one because this was a little bit messier to try and factor. And so you can see I have u, not x, we're working with u here, is equal to the opposite of b, -4, plus or minus square root of b squared, 4 squared, minus 4 times a is 12, times c is -1. Again, be very careful of those negative signs. You don't want them to bite you and cause a problem. So when I clean this up, -4 plus or minus 4 squared is 16. 4 times 12 is 48. With another negative there, though, makes it a plus 48 all over 24. Then I had to go up over there. 1648 is 64. So -4 plus or minus the square root of 64 over 24. Now, square root of 64 is nice. It's just 8. So I broke this up into 2 parts. It's getting a little messy here. This is the problem of trying to teach on a little tiny board. So here's the first one. -4 plus 8 over 24. -4 and 8 is 4. 4 over 24 reduces down to 1 over 6. So there's the first solution. Well, intermediate solution, I guess, that we get out of this. The second one, the or, -4 minus 8 now, using that minus sign, is -12 over 24, which gives us a -1/2. So we have these 2 possibilities, but they are possibilities for u, right? These are both u values, not x values. So now we have to do our reverse substitution, right? We said u is equal to x squared. So now we're going to set x squared equal to 1 over 6 and x squared equal to a -1/2. So I'm going to solve both of these just by taking square roots, so it works out pretty nice. The square root of 1 over 6 gives me plus or minus the square root of 1 over 6. Remember, I can split a radical across a fraction. So the square root of 1 is just 1, and we had that ugly square root of 6 on the bottom. But we don't like that on the bottom, so I just rationalize the denominator. So I did that again by multiplying by that square root, top and bottom. Because remember, if you multiply the square root by itself, you always just get the thing on the inside, in this case 6. So we end up with plus or minus square root of 6 over 6. 2 solutions already. That's only half of it. I've got 2 more coming over there. Isn't that fun? I think so. And get it if you don't, but I think so. All right, so here we go. X squared is equal to a negative half. Don't cross this one out. This one is going to give us some more solutions. We can have a square equal to a negative number because we can take the square root of a negative number. It's just going to supply us with an I. So let's walk through this. I took the square root of both sides. So here, again, I don't forget the plus or minus. Plus or minus square root of negative half. The negative pulls out an I. And I took the square root of 1 and got 1 and left the square root of 2 on the bottom. But again, we don't like the square root on the bottom, so I multiply top and bottom here by the square root of 2 over... I multiply them both by the square root of 2, and that cleans it up. Root 2 times itself just gives me the 2 on the bottom. So I have plus or minus I times the square root of 2 over 2. You can put the I in the numerator, and that would be okay. You could technically put the I after it too, and that would be fine. It really doesn't much matter where that I is. Just don't put it on the bottom. That would be a bad place for it. So there we go. That is quadratic form. You're going to get some big, messy problems here. Take your time. Show those steps really well. Be neat. Neatness is a really valuable thing. And we'll go from there. So thanks and good luck.